So this is the GM counter module. It's got an onboard processor, some pulse counting circuitry. As for interfaces, it has USB as well as I2C. This is the HV generation module, which is controlled by a 12-bit DAC. And here you have the necessary circuitry to connect it to a GM tube. Now it comes with this couple of clips with which I can connect it to a GM tube, such as the LND712 that you see here. So the red trace goes to the center of the tube, and the black one goes to the body of the tube. It's not connected yet, which is why. But even if it is connected, because it goes through a 6 meg input impedance, it's pretty much safe to, it won't shock you. Now this is CSHM 137, and I'm just going to plug this into my laptop. So now that I've plugged it in, it's no longer safe to be around this because of the high voltages. Even though this part is not going to hurt you, this can actually supply HV to a PMT also on the back side. If you look at the connectors here, it's actually available without the 6 meg series. Okay. Now I've placed this in front of the CSHM source, and there's a little orange light that indicates that it's on. There's another green light which will tell you when it's counting. It's not counting right now. Now let me switch over to the software. So there's a small web app here. But before we get to the web app, let's access it using just the terminal. So this has Skippy commands support. So let me use minicom. I'm on Linux, so instead of COM ports, it will be TTY ACM 0. Enable carriage return, enable echo. V question mark gives you the version, and var question mark gives you the extended version. Volts will tell you what is the voltage currently present at the output. Set V will allow you to set a voltage, let's say set 400 volts. Okay, so within about 2% it will be accurate. If I pull up a multimeter and try to measure this, let me switch back to the video feed. So I can carefully measure the actual HV that's present at the HV module. So if you measure at the GM's output, you won't actually get the exact HV that's present because of the impedance of the multimeter itself. But if I put this here and connect it to one of the grounds, you can see that it's about 411.5 volts. Okay. So even this can be calibrated if you want very exact voltages. So let's just flip it back and go back to the screen share. Right, so now I have this set V here. There's the source here. Right. Now to start the counter, I can just say start. Sorry, there's some stray characters. And it's response with OK. Now count question mark. I'll say OK. There are no counts yet. So let me set a higher voltage, say 450 volts. So now it has started counting. You can see the counts increasing, right? You can also set time limits and other things, but this just demonstrates that you can use it with just a terminal and Skippy commands. Now I'm going to show you the small web app. There's also an Android app. This is easy. So this works only on Chrome, by the way, because it uses web USB, and the link is online. So it's detected here and connect. So now it's connected. The version numbers have appeared. The tube rated voltage, the maximum voltage which you do not want to exceed for a particular tube, you can set here. Counts per second. If it exceeds 5000, it will automatically drop the voltage to prevent damage to your tube. Let's start with, let's say 450 volts set. Right. So you can set for different voltages, let's say 800 volts, and see what is the count rate. Okay, so it's going to be fairly the same around the operating range for LND712 is I think about 400 to about 8 or 900, I'm not sure. But you can also use this sweep thing where you can set it from let's say 300 to let's say 1000 in steps of say 50 volts each. And let's acquire for, okay, 15 is low, 5 is also low, but just to demonstrate. So now it will first set 300 volts and say, okay, how many counts did I get it in 5 seconds? You only got about 0 counts. Again, 350 will still be 0. 400 you might get something, not sure. 450 you'll definitely get something. Yeah, so about 20 counts, and this way it'll get you the entire plateau thing till you hit the threshold of CPS, which you've set to 5000. Yeah, so obviously there will be statistical fluctuations here because we're taking for a very small duration of time, so it's not very reliable data. But if you take, for example, let's say 30 or 60 seconds, you might get something more uniform, which I will probably end at the introduce at the end of this video. Okay, we're already at 800, or 950 or 1000. It will start going here. You move into the continuous. Yeah, so see, 900 breakdown voltage protection triggered, and the count rate hit 7100 CPS above the threshold. Therefore, the bias has been reduced from 950 to 850. So your tube is not damaged. So I think this clears up how to use the web app. Now I need to show you the Android app. So let me just switch to the Android thing. So this is the Android app you'll find on the Play Store. You can just search for GM Counter and CSPA, and you need an OTG cable to connect it to Android. So this thing is powered. Let me just disconnect this. Be a little careful, not go to the HV side of things. I've just removed the USB cable and connect the cable that's hooked up to my phone here. Okay. So now when you connect it, it asks for permission to connect to a phone here. Okay, so okay, this says device found, CSGM 2.2. You can set the operating voltage, let's say 600 volts here. Set it. Okay, now you can start counting. So you see, the counter here is active. It's showing you some counts. Let me put the source right in front of it. And so this is a free running counter. You can also set the duration in seconds. For example, I want to count for 20 seconds or 10 seconds. So now this has become a countdown timer. And this is like counting down to 10, and it'll tell you when it finishes 10. We got about 57 counts in 10 seconds at 600 volts. And that's pretty much it. There is visual programming built into this, where you can do stuff like count and plot. So here these are all blocks which you can attach and create small programs. So I have a loop which says, okay, start counting, set a variable called CNT to counts, and you plot count versus time, and you also show the counts as a label and do this every 1 second. So you should get like an increasing graph. We did not set a voltage initially, so whatever voltage was set will be used. So perhaps I should set a voltage first. So set voltage to about I don't know, 650 volts. Okay, and run this. So now this program is actually running, and it's just plotting the cumulative counts that it has acquired over time. And you can get a straight line fit of this and get what is the counts the slope of the graph will tell you the counts per second. So that is visual programming for you. You can actually get your plateau with this, by setting different voltages and getting counts for a certain fixed interval of time. So it's fully programmable in drag and drop visual programming systems. And this data, of course, you can save as a CSV file and other things. Okay, so let me just abort this because there's no condition to stop this program. There's no, it's a while true sort of thing. Let's just go for stop, abort, go back, and yeah, that's it. Nothing more to it. Good. So thank you for coming to my TED Talk.